So convection is the transfer of heat from one place to another due to the circular movement of a fluid. This fluid could be a gas or a liquid. It's obviously not going to happen in a solid because you need the particles to be able to move freely. So convection only occurs in a fluid. And what's actually happening here is you have hot fluid rising up, then cooling, and cool fluid then sinks, which can cause a circular motion of heat transfer. And we call that circular motion of heat transfer a convection current. This is an example here. In an oven of a convection current, you have air being heated at the bottom, which makes it less dense and causes it to rise. When it gets to the top of the oven, relative to the bottom, it's actually cooled down a little bit. And when it cools, it becomes more dense. And you can see there, it's actually starting to sink again. That circular motion, again, we call that a convection current. And it happens in any fluid, be it a liquid or a gas. So think about over here at home, you've got your fire on or your heater on. That fire warms up the air, causes it to become less dense, which makes it rise. Once it cools, it becomes more dense and it sinks. And you set up this convection current here. Also, you can have it if you heat up some water, you boil something on the stove, you heat the water, becomes less dense and rises. Once it cools down, it becomes more dense and sinks again. So let's put down here as well a hot fluid is less dense. That's why in a convection current you can see the hot air or hot water, whatever it happens to be, rising because it's less dense. If you have a cold fluid, more dense. That is why, again, in a convection current, you have hot fluid rising because it's less dense, and when it cools down, it becomes more dense and it sinks. Here's an example out in nature. I think I've mentioned before about thunderstorms being caused by convection. So you can see here you have a sea breeze during the day. So in summer, in the afternoon in particular, you're going to have these winds that blow in from the ocean onshore. So you have an onshore breeze because the sun is heating up the land. As that land heats up, it causes the air above it to warm, become less dense. And you can see here, rise. Once it reaches a certain altitude, it will cool down and it'll start to sink down over the ocean here, setting up another convection current. So this is during the afternoon or during the day. You have the onshore breeze, and then at night, the land will actually lose that heat that it picked up during the day, and the air will start to rise above the ocean here. So you'll get rising, warmer air off the ocean, and at altitude, it starts to move back across onto the land, sinks back down, and in the morning, early in the morning, you might find if you go to the beach, you've got these nice offshore breeze, so the surf's nice and clean, because of this idea of a convection current being set up with warm air rising off the ocean, cool air sinking back down over land, and that convection current being set up in the opposite direction as you'd find it in the afternoon with those strong sea breezes. Radiation. So another method of heat transfer here. This is heat transfer through infrared waves, which is a type of electromagnetic wave. So electromagnetic wave includes light that you and I can see with our eyes. Infrared waves, the wavelength, they're too long for us to see with our eyes, but everything radiates infrared radiation, and it travels at the speed of light. Radiation can travel through a vacuum as well, so the heat from our sun transfers to Earth through radiation. It doesn't need a fluid like convection does to actually transfer that heat. It can do it through a vacuum. When it hits a surface, it can be absorbed, reflected, or transmitted. So if you have a look down here, and I want you to put this down as well, we have dark colors. So it could be a dark t-shirt, it could be a dark car, like a black car, for instance. You might have heard people saying that black cars are really hot if you leave them out in the sun. The reason being, these dark colors are really good at absorbing all of the wavelengths of light or radiation that hit it and stores that heat energy within it. So if you wear a black t-shirt in the sun, you get pretty hot. Conversely, you wear light colors or you have a white car, a lot of that radiation is actually going to be reflected off that surface. So it won't heat up as much. So again, a white t-shirt out in the sun, you probably won't feel as hot as if you're wearing a black t-shirt that's absorbing all of that radiation. Obviously, glass, clear materials, they'll actually allow the radiation to transmit through it. You have a little bit of absorption, but most of it will go straight through. Heat transfer radiation is invisible to the eye. So that's what I was saying before. It's infrared. We can't actually see this type of heat transfer. But again, like we've said before, it's heat being transferred from high to low temperature.